Alright, so in this lesson, we will learn how to identify horizontal transformations given in a function notation. I didn't mention this in the last lesson on vertical changes, but these are easier to see in like tables, but the way they want us to learn them is in terms of like geometric transformation, so to speak. So I'm going to show them to you visually, and that's why I'm showing you the graphs rather than the tables. All right, so we're going to identify the horizontal changes to a function. All right, so in the last one, we changed f of x. We added to f of x, we subtracted from f of x. We multiplied by f of x. But in today's lesson, we're not going to do anything to f of x. We are going to do something to the x. We are changing the x. We are changing horizontally. So, in this first one, it says f of parentheses x minus 4. Last time, we moved down 4. But remember, we're doing horizontal today. This is still going to be a translation. But instead of moving down 4, we are going to move right 4. So every one of these points moves right 4. That's where it would be over there, right? Every single point on here moves to the right 4. F of x is right here, our original. And then when we add 4, we actually move left 4. We can even choose the middle one. It's just kind of a little bit harder to do or to show accurately or precisely. So we're still like in this one, we're moving left. But this is kind of opposite of what we think of. When we think minus 4, we think left 4 on the number line. And when we think of plus 4, we think of right 4 on the number line. But as you can tell, when you subtract 4 from x, you're actually moving to the right 4. We can get into why that is later, but for now, just know that. So it says minus 4, so we're instead of moving left, we're actually moving right, or translating right. 1, 2, 3, 4. Let's try this one. 1, 2, 3, 4. Yeah, they're all to the right 4. 1, 2, 3, 4. They're all translated right 4. This one, even though it says plus, when we add to the x, it's actually going to move left 4. 1, 2, 3, 4. Same for the cubic function. Everything's moved left 4 when you add, everything's moved right 4 when you subtract. So when we subtract from x, not from f of x, just from x, it's actually going to move right. And when we add to x, we're actually going to move left. Alright, let's see what happens when we multiply. Alright, so remember, we're multiplying by x. We're multiplying x by a number, right, by a value. Not f of x. We're not multiplying by f of x. We're multiplying by x. Okay. So 5/10. Yesterday, 5/10 was a compression, a vertical compression. But like yesterday, or like the last lesson, sorry, I'm so used to seeing out during class. It's easier to see these compressions and stretches using a quadratic. So 5/10, when we multiply the x times 5/10, you can see this is our original, and we get wider. And this is our original. When we multiply the x by 2, we actually got skinnier, we got narrower. The function becomes narrower. Last time we had to worry about up and down because we were doing vertical, but this is like way easier in terms of compressions and shrinks. So we can tell that when we multiply by a digit or a number with an absolute value between 0 and 1, then you get wider. It's a stretch. This is a stretch. On this one, if we're talking about in terms of left and right, in terms of horizontal movement, we're pushing, we're compressing. And the same, we can think about it that way. This is harder to see, But remember, we're pulling like a string in opposite directions, and then it comes out like this. This one, we're taking our original string, and we're like, oh, remember we're compressing it. Yes, we're compressing it. So we are moving it, we're pushing it that way. Same for that, but it's easier to see in the other, and especially quadratic. So when we multiply by a digit between 0 and 1, like here, we got wider by horizontally stretching. When the digit, regardless of the sign, is greater than 1, let's check it again. We pushed it together horizontally. So this is the opposite of vertical. So this is going to be a compress. Right? And lastly, let's check this out. Just like the lesson before, this is going to be another reflection. The question is, well, this is going to be a horizontal reflection because we're doing horizontal like transformations. And remember, you're taking all the x values and you're making them the opposite of what they were. So you're taking, like, if it was like 1, 1, now it's going to be negative 1, 1. If instead of 2, 2, it's going to be negative 2, 2. Like, so we're moving horizontally. Like everything on this side is coming over here, so to speak, and all the points on this side are coming over here. Let's make sure that's true. Now, this is kind of hard to see because this is our original. And if you were to flip everything over here and everything over there, over here, then you just end up on top of itself. It's a little hard to see here too because you don't know whether you're moving up and down or whatever. But remember, we're multiplying the x values. We're making them the opposite. So this was over here, now it's over here. This is over here, now it's over here. But even though we're reflecting horizontally, we're going over the... That doesn't look too nice, so I'll just get rid of that. We're going over the y-axis. Flipping over the y. So when you multiply by a negative number, and in this one, we're multiplying by negative 1. Let me try that one more time. By negative 1. Then we are going to reflect horizontally, because remember we're doing horizontal, over the y-axis. Alright, one more section of notes. Now let's learn how to identify these. Let me just zoom in a little bit. Alright. So, remember a cheat sheet right here, or cheat notes right here, I guess. And so if we're on the inside, normally we would think going right, translation, right? Normally we think going right, but remember it's the opposite, so we're actually going left 1. In this one, the second one, we have this negative sign to all the x's, so we know it's going to be a flip, a reflection. Now remember that if we flip, like if I'm over here and I'm flipping horizontally, I'm actually going over the y-axis. Now here, I have to be careful. These ones, because remember, they're different from the vertical. So I go over here, 0 and 1, horizontal stretch. So it's going to get fatter. So compared to where it was. So it's a horizontal stretch by a factor of 25 hundredths, or 1/4. Oh, now we have 2. So I like doing this part first. We subtract 3, which makes me think left 3, but we're actually moving right 3 units. Then we have this horizontal reflection over the y-axis again. And lastly, this, if we had like a quadratic, would make it skinnier. So it's going to be a horizontal compression by a factor of 3. Remember, we don't include the negative because the negative is with the reflection over the y-axis. So this is the negative part, so to speak. And this is the 3 part. Do not put the negative with the 3 because the negative is there for the reflection. The 3 by itself would be the compression. And that is it. Thank you.